Hello everyone, welcome back to another spatial statistics lecture video. And in this lecture video, I want to go through the first of the spatial lag models. And that is going to be the spatially lagged X model. So let's go ahead and remove our results from the previous video, and let's do a spatial lag X model, okay? So, as we've talked about in the lecture videos, the spatially lagged X model is basically an approach of saying, hey, we think that not only do my changes to the independent variable affect my dependent variable, but also what my neighbors are doing to their independent variables will affect my dependent variable. And we've already kind of talked about how this spatial lag model is basically just a way of incorporating the spatially lagged means, right, or the average of my of adjacent neighbors into a regression equation. And so the way that we're going to approach this is with something called the spatial LMSLX function from the spatial reg package. So let's just quickly look that up. So again, spatial reg is the name of the spatial regression package. And then we're going to be looking up something called LMSLX. Okay. So the spatial Durbin linear model, that's just another name for the spatially lagged X model. Okay. And so if we look down here at the formula, right, or the parameters, right, it's going to look very similar to what we had in the previous video, or the previous regressions, right? So it takes a formula just like before. It takes data just like before. What it takes now, though, is this list W, and this is going to be that exact same spatial weights matrix. Okay, so this is going to look very similar to what we've done in the past. So we're going to do a spatial lag X model, and we're going to set that equal to, again, spatial reg for the spatial regression package, colon, colon. And then we're going to do LMSLX. Okay? This is going to take the formula. It's going to take data. It's going to take the list W. Okay? So formula, again, this is going to be the exact same thing. This is going to be the cancer rate regressed against smoking. Okay. The data is going to be pen underscore UTM at data, because this is the data frame associated with the spatial polygons. And then this list W here is going to be the spatial weights matrix. So this is going to be pen underscore SW. So again, just to recap, formula, data, spatial weights matrix. This is very similar to the construction we've seen before. And if we run this, we see that nothing happens, which is perfect. We didn't get an error. If we want to investigate it a little bit, we're going to use the summary function just like we did with the regular OLS. And we're going to summarize the spatial lag X model. Oops. If we run that, right, you'll see here that we have something very similar to what we've seen in the past. But now you'll see that we have the smoking here, and then we also have this lag of smoking. So this lag of smoking, this is going to be this estimate, right? This is the theta. If you remember back to our equation for the lag model, right, we said it was Wx theta, right? This is the theta. This is the beta. So this is the effect of smoking on us, and this is the effect of our neighbors smoking on us. Okay? So put another way, and we're going to talk about, actually, let's do this first. So with the introduction of these spatial dependencies, right, we've introduced this idea of direct and indirect effects. And we summarized those briefly in the lectures as saying that direct effects are what happen to me when I change my X. And indirect effects are what happened to me when my neighbor changes their variable. Okay? And that's what this lag smoking is showing you, saying, how does my neighbor's smoking affect me? Now, I'm going to introduce this right now because with the lag y and the error, interpretation gets a little more difficult. And so what's nice about the spatial regression package is that they actually have something called impacts. So if we type in spatial reg : impacts, right, impacts in spatial models. So what this is going to do is this is going to basically allow us to convert the beta and the theta into this idea of direct and indirect effect. So if we go up here, you can see that what it takes in as a argument is the object. So this is going to be the spatial lag model and the list W, which is going to be the spatial weights matrix again. So again, we're getting the same sort of stuff. So if we do impacts, actually, let's make sure we call it from spatial regression just to make sure we're not getting something wrong here. Spatial regression : impacts. The object, this is again the model, so this is going to be our SLX. And then it takes in the list W, which is again our pen underscore SW. If we run this, right, you'll see that underneath it, right, direct, indirect, and total. So the way that we interpret this, right, the direct effect, this is what happens to us when we change our smoking. So basically we would interpret this as if we increase our smoking, we increase the cancer rate by this amount. The indirect effect is what happens when our neighbors change their variable. So this would be when my neighbor changes, it increases my smoking rate by 7.6. Or flipped around, when I increase my smoking, I raise mine by 15, and I raise my neighbor's by 7.6. Okay? Total is, in this case, total is the sum, right? It's the sum of these two. And total is basically saying overall what happens when we raise smoking. Overall, when we raise smoking, we see an increase on average of basically 23. So this is going to show us the overall impact of changing smoking on cancer rate. Direct is on the individual raising itself. Indirect is on the individual versus its neighbor. And then total is going to be the overall cumulative impact of changing the variable. Hopefully that makes sense. And as always, please reach out. Thank you.